When you are performing an experiment, you may not be able to get the expected results, even though you have followed the teacher's instructions and the methods described in the textbook. Your failure to master certain basic experimental skills is to blame. Let's take a look at these skills. This is a meter rule, which is used to measure the length of objects. It is simple to use. All you have to do is to place the meter rule horizontally along the object you want to measure, putting the side with the graduations next to the side of the object. The length of the object is indicated on the other end of the meter rule. However, certain skills are necessary to ensure accuracy of the measurement. These two students are measuring the length of a book with a meter rule.
.6 cm.
Why do they get different readings? The thickness of the ruler will lead to larger measurements if you lean your head to right. The measurement will become smaller if you lean your head to the left. The measurement obtained is affected by your angle of vision. To obtain an accurate reading, your head should be vertically above the mark of the meter rule. The girl leads her head to the right when reading the mark. Therefore, her reading is affected by parallax and becomes inaccurate. The boy measures with the worn-out end of a meter rule. Therefore, his measurement is also inaccurate. If the end of the ruler is worn out, you should start at the 10 centimeter mark. Your head should be vertically above the mark while you're setting it. Having set the initial point, you may take the measurement at the other end. Likewise, your head should be vertically above the mark. Deduct 10 centimeters from the reading and you will obtain the length of the book. If you want to measure the volume of an object, you need a measuring cylinder. Pour some water into the measuring cylinder and record the water level. Then, place the object to be measured into the water. And record the water level again. The volume of the object is the difference between the two readings. You should be careful in taking the measurement. First, the measuring cylinder must be placed on a flat surface. If there is a pile of paper under the cylinder, the reading will become inaccurate. Second, use a measuring cylinder of suitable size with appropriate amount of water. You have to place the object inside the water gently to prevent water from splashing. If there are air bubbles in the water, you must wait until they disappear before taking the reading. Third, since the top of the liquid is slightly curved, you should take the bottom of the meniscus as the actual water level. Your eyes should be at the same level as the meniscus. But the surface of certain liquids, such as that of mercury, bends upwards. When you are measuring the volume of such liquids, you should take the reading on top of the curved surface. Your eyes should be at the same level as this point. To take out a solid chemical from a bottle, unscrew the cap of the bottle carefully and place it onto the bench. Remember to place the cap with its inside facing up. Use a spatula to take the solid chemical out of the bottle and place the chemical on a watch glass. If a spatula is not available, how can you get the desired amount of the solid chemical from the bottle? Just tilt the bottle and rotate it slowly. The chemical will come out from the bottle bit by bit, and you can collect the desired amount. Don't tap the bottle. An excessive amount of the chemical may be forced out, causing wastage and contamination. If you want to transfer the chemical into a test tube, use the small end of the spatula and act gently. Or you can use a piece of folded paper to scoop out a suitable amount of the chemical and place it into the test tube. Don't pour the excess chemical back into the bottle, because the chemical might have been contaminated. Placing it back into the bottle may spoil the whole mass within. If the chemical is poured into the wrong bottle, it could cause vigorous chemical reaction. This is a bottle of liquid chemical. If you want to get the liquid, you should open the bottle in the following way. Remove the glass stopper with your palm and your fingers. Hold it between the palm and the fingers while the liquid is being poured out of the bottle. Replace the stopper immediately after use. If you need only a small amount of liquid, use a dropper to transfer it into a test tube. But be careful not to let the dropper touch the substance inside the test tube. You must not use the same dropper to deliver more than one kind of liquid chemicals, as this would lead to contamination of the liquids in all the bottles. Don't use too much liquid chemical at a time. A little will be enough for reaction to take place in most cases. Too large an amount may lead to vigorous reaction, which is dangerous. How can we mix two liquids in a test tube? Clean the surface of the upper end of the test tube and wrap it with tissue. Clamp it between the thumb and index finger of your left hand and hold it up. Gently tap the index finger of your right hand on the lower end of the test tube repeatedly until the two liquids mix up thoroughly. Never swing a test tube with your thumb covering the opening. Your finger may contaminate the liquids, or the liquids may cause harm to you. Remember to place the test tube upright on the test tube rack. Pour the liquid out from the test tube and wash it immediately after the experiment. The Bunsen burner is used in most experiments, such as finding out the melting point of substances and evaporating a solution. But do you know how to use a Bunsen burner correctly? If you use a match to light a Bunsen burner, put the burning match on top of the burner before turning on the gas tap. If an igniter is used, put the igniter on top of the burner and turn on the gas tap. Then, immediately switch on the igniter to light the burner. Whether a match or an igniter is used, you should check if the air hole is closed before lighting the burner. Do you know why the air hole should be closed before lighting the Bunsen burner? If you light the Bunsen burner with the air hole open, the flame will burn inside the tube, giving out a sharp noise. This phenomenon is known as striking back. If the air hole is opened, the air rushes into the tube and the gas burns before it gets to the top. The wall of the tube soon becomes red hot. If your Bunsen burner strikes back, turn off the gas tap and wait until the tube has cooled down. When you are heating chemicals with the Bunsen burner, bear in mind the following precautions. First, light the burner at an arm's length to avoid burning yourself. Second, adjust the air hole to 1/3 of its full size. Third, if you're heating a liquid, do not fill more than 1/3 of the test tube with the liquid, as the boiling liquid may spill from the test tube during heating and burn your skin. Fourth, wear goggles to protect your eyes against spillage from the test tube. Fifth, use a suitable test tube holder to hold at the upper end of the test tube. Move the test tube to and fro slowly so that it will be heated evenly. The center of the flame contains unburnt gas. Do not use it to heat the test tube. Also, when the liquid in the test tube begins to boil quickly, withdraw the test tube to avoid spillage. 6. Never point a test tube towards anybody. It's dangerous. 7th, turn off the gas tap after using the Bunsen burner to prevent accidents from happening. In some experiments, it may be necessary to dissolve solid chemicals in water. A number of safety cautions should be taken. Do not dissolve a large mass of solid chemicals in a tube of water. The excess amount cannot dissolve and will be wasted. To speed up dissolving, you can use a glass rod to stir the mixture gently. Do not poke the solid at the bottom of the test tube with the glass rod. It will not help dissolving the solid, but may break the test tube instead. If the chemical does not dissolve completely, add more water into the test tube. You may heat the mixture in the test tube to help dissolving the solid. However, if you are dissolving solid chemicals in flammable substances such as alcohol, do not heat directly over the Bunsen burner. The safer way of heating is as follows. First, heat a beaker of water. Then, put the test tube of flammable substances into the boiling water to warm the substance with the heat of the water. This is called a water bath. Flammable substances can be heated safely in a water bath. Mixtures may be produced in the course of some experiments. To separate the substances in the mixtures, we can use the following methods. Here is a mixture of sugar, sand and water. To separate sand from the mixture, place the beaker aside and wait until the sand sinks to the bottom. Pour the liquid from the beaker along a glass rod. The sand remains in the beaker. This is called decantation. It is effective for separating large and insoluble solid from liquid. If a suspension is formed in the beaker, the substances should be separated by filtration. This is a filter paper. Fold it up twice. Then, pull out the opposite sides to form a cone and place it in a filter funnel. Add a few drops of water to the filter paper and stick it onto the surface of the funnel. The particles in the suspension are trapped by the filter paper, while the liquid runs out of the filter funnel. The filtrate is a clear liquid. It is a solution of sugar dissolved in water. The sugar can be obtained from the solution by evaporation. Pour the filtrate into an evaporating dish. Put the evaporating dish onto a wire gauze on the tripod. Light the Bunsen burner to heat the solution. Water evaporates away and sugar is left on the evaporating dish. Turn off the gas tap when there is only a little water left. Otherwise, particles may be ejected out. Wait until the evaporating dish has cooled down, then lift it with a pair of crucible tongs. Now, can you separate copper sulfate and chalk powder in a mixture? It's simple. Place the solid mixture into water to dissolve the copper sulfate. A mixture of solid and liquid is formed. Then, separate the mixture by decantation, filtration, and evaporation. Some experiments will give off gases. But how can we collect these gases? All we need is a length of rubber tubing and some water. Invert a test tube of water into a water bath. Connect one end of the rubber tubing to the reaction flask and place the other end into the inverted test tube. The gas produced during the reaction will come out through the rubber tubing and displace the water in the test tube. When the water in the test tube is completely replaced by gas, block the opening of the test tube with a rubber stopper. This way of collecting gas is called collection over water. Let's review the basic experimental skills. Measuring length and volume. Handling chemicals. Mixing and separating chemicals. Collecting gases. When performing experiments, mastery of the basic experimental skills will help you obtain accurate results and prevent laboratory accidents.